चेंज ऑफ वेरिएबल का एक क्वेश्चन है. इफ v इज ए फंक्शन ऑफ r and where r² is equal to x² plus y² plus z², then show that d²V dx² plus del²V del y² plus del²V del z² equals to d²V dr² plus 2/r dv dr. So v is equal to function of r. Since v is a function of single variable r, differentiation of v with respect to r is total if differentiating v with respect to r, and r is the function of x, y and z, then differentiating r with respect to partially del x, partially x, partially y, partially z. Since r² equals to x² plus y² plus z², then differentiating partially with respect to x, we get 2r del r del x equals to 2x. Hence del r del x equals to x by r, and v is equal to function of r. So del v del x equals to, by chain rule, del v del r into del r del x, and del r del x equals to x by r. So this is equals to x by r into dv dr. So del v del x equals to x by r into dv dr. Then we use the operator del x. We cancel v, then we get del x equals to x by r del r d dr. This is an operator. So del²V del x² equals to d dx of del v del x. So this is equals to del x, and del v del x equals to x by r dv dr. So with differentiating with respect to x, we get 1 by r dv dr plus we x into differentiating this 1 by r. So this is equals to this plus, and del x equals to x by r d dr. This is an operator. Then we get, with differentiating, this is equals to this and this into this x² by r, and differentiating with respect to dr, at first differentiating 1 by r, so we get minus 1 by r², and this is dv dr plus, and differentiating this, so this is equals to 1 by r into d²V dr². So del²V del x² equals to this, and this is equals to this, multiply this, then we get del²V del x² equals to 1 by r dv dr minus x² by r cube dv dr plus x² divided by r² d²V dr². This is equation number 1. So this is क्योंकि x² by r into this, then we get this is del²V del(x²) equals to 1 by r dv dr minus x² by r cube dv dr plus x² by r² into d²V dr², and replacing x by y and z, we get for symmetry, if we replace x by y, then we get del²V del(y²) equals to 1 by r dv dr minus x की जगह y, so this is equals to y² by r cube dv dr, and replace x by y, then we get y² by r² into d²V dr², and del²V del z² equals to, we replace x by z, 1 by r dv dr minus z² by r cube dv dr plus z² by r² d²V dr², replacing x by z. Then this is equation number 2 and this is equation number 3. Then adding 1, 2 and 3, we get del²V del(x²) plus del²V del(y²) plus del²V del(z²) equals to 1 by r 1 by r 1 by r 1 by r, so 3 by r dv dr, and this is minus common x² by r cube plus y² by r cube plus z² by r cube into dv dr, and this is x² by r² d²V dr² plus y² by r² into d²V dr² plus z² by r² d²V dr². So this is equals to 3 by r dv dr, and this is equals to x² plus y² plus z² divided by r cube dv dr, and this is equals to plus x² plus y² plus z² divided by r². If we LCM of r², then we get d²V dr². So this is equals to 3 by r dv dr minus, and x² plus y² plus z² equals to equals to r square. Then we get r square by r cube into dv dr plus, and this is equals to r square by r square, so this is equals to 3 by r dv dr minus 1 by r dv dr plus d²V dr², and this is 2 minus 1, 3 minus 1 equals to 2 by r dv dr plus d²V dr². So therefore d²V del x² del 2v del x² plus del 2v del y² plus del 2v del z² equals to d²V dr² plus 2 by r dv dr, hence proved. So this is proved.